In Jeffersontown, Kentucky, at the local elementary school, Mary Holden teaches a combined 4th and 5th grade class. During mathematics lessons, Ms. Holden often divides her students into 3 groups, each doing a different task. Over the next few days, the students then rotate from group to group.
Okay, go to your groups. Come with me on the floor. The children really look forward to working independently. They love it. Setting up the computers and working on them by themselves and solving their own problems and you know, that's my push is, you know, independence. That's what they're doing. The other independent group is called Puzzles and Games, and they just work on something perplexing. Like today they were working on tessellations. They had already made their tessellating figure, and they were tracing them over and creating designs.
While the other groups work independently, remaining students gather around the teacher. Ms. Holden begins by having them explore Base 10 blocks. It's an introduction to a lesson examining different forms of computation.
Once again today we're going to move back to another idea about these base 10s. Is this is going to be one whole, okay? If this is $1, what is this? 10 cents? And what is this?
A penny.
A penny, okay. So like for instance, this would be $1. How much is this altogether?
$1.11.
11, okay. Now, which one of these structures that you all built would cost the most?
Aubrey's. Probably.
Okay.
I got maybe. Not his. Natalia's.
Okay.
Andy's
Okay. Okay. Now let me get down to tell me why you think so and what do you think it's worth? Okay, Prib.
Well, Natalia's. It has $2 bills and a lot of 10 and dimes.
So real quick, give us an estimate what you think Natalia's is worth.
273.
You would call it 273 or what? These are
$2.73.
Okay. Who else thinks there's one more valuable than Natalia? Christy?
I think it's Aubrey's because Natalia has a lot of ones in hers, and Aubrey's is built mainly of tens and hundreds and wholes.
We used money just to make it seem real and to come up with some real-world applications. I really don't think that isolated lessons with some, you know, printed-out problem is probably good learning. Learning it within the context of the situation is the best.
I think Andy's would be more than the other ones because there's a lot on the outside. There's mostly tens and holes, and there's a lot inside of it.
Mm-hmm. And how much do you think it's worth?
I'd say $3.48.
Okay. Okay, let's do the count. Go ahead. And as you trade in, would you say out loud as you trade them in?
20. There's 3 right here. No. You don't have to take those out yet. Just take these. 90. $2.
Okay. $3. No, $4. 60.
80 cents.
Natalia, give me yours. How much is yours worth?
$3.58.
Well, look at the difference. This was our estimate, and this is what it really is. This is the truth. We were way off with hers, weren't we? Okay. Aubrey's.
$4.20.
Ooh. Look at the difference, though. Well, if somebody told you that yours was worth $500.50, would that sound reasonable? No. Were we close enough to be reasonable?
Yeah.
Okay. Andy.
$4.01.
Okay. As a group, would you say that we are underestimators or overestimators? I know. Sometimes you need to know that about yourself so that next time you estimate, you know to aim just a tiny bit higher with your estimate. Okay. Would you show us what 23 cents looks like? Is that 23 cents? Look at it again. Oops. Oh, no. Okay. Is that right? Is he right? Okay. Now, what happens if he's got 23 cents there and He really would like to have 5 times that much. How could he make that with the base 10 materials? Help me out. You tell him what to do. He'll obey you. He's not going to do it on his own. He'll do what you tell him to do. You can tell him what to do. Tell him what to do.
Multiply 5 times 23 and put separate piles of 23 cents in different piles.
I try to set up a classroom or learning situations where children are experts and they're teaching others. And sometimes it has to be under real intense guidance on my part, but that's what it's all about. Is 23 cents, what kind of money is that close to?
A quarter.
A quarter. How much would 5 quarters be?
$1.25.
Is that close to $1.25?
Yeah.
After solving several problems with the base 10 blocks, Ms. Holden challenges the students to calculate using other methods of computation.
Okay, you're on paper pencil, you're on calculator, you're on mental math, you're on base 10, and we'll rotate. We'll go around a notch. I'll give you some problems, okay? Slushies are on sale today for 29 cents, and you're going to buy everybody that sits at your table one. How many people sit at your table? 4. I had the kids use different kinds of computation. I had them use calculators, paper pencil, I had them use mental math, and I had them use the base 10 materials, manipulatives, just to see how efficient they were and how quickly they could work and how they could observe each other while each was solving the same problem but using a different technique. Okay, while poor Aubrey is sweating away at the method of 10s and 1s, we will ask, what's the answer, Tara?
33 cents.
Now, the slushies cost 29 cents and you're buying 4 of them. It's going to cost 33 cents. What?
$1.16.
Crib?
I'm totally off.
Okay.
I know that.
Okay.
What'd you get?
It's totally off.
Say it out loud.
$2.48.
Ooh.
I told you.
I got 47 cents.
Because that sounds reasonable.
Not
The
from
slushie
what
costs
everybody else has been
I know it.
saying.
29 cents and you're buying 4 of them?
I kind of did like the problem was on the board. I did it like that in my mind.
Let's
It didn't work.
think that through. Let me give you a
Didn't
little
work.
trick with a 29 one. Okay? 29's hard to work with, isn't it? If you think in your mind 4 times 29, that's hard to do, isn't it?
Yep.
What's 29 close to?
30.
30, okay. Then you do what?
You take away a penny
And then
for
what do
each
you come up
one.
with?
$1.16.
That'll work.
Say like you want to equal up 29 times 4.
Yeah.
You can use the tens first when you're done with the count up the tens, you use to count up the ones.
Okay, so like this is a 10. Can I use my hands with this? Okay, watch this. 10, 20. Is that one of them?
Yes.
30, 40. Is that another one of them?
Yes.
50, 60. Is that another one of them?
Yes.
70, 80. Okay, now is that all the 10s?
Yes.
Okay, now what's the ones?
The nines.
Yeah, 9s. Okay, how many of those did you have?
4.
What's 4 times 9?
36.
Okay, so here, what do we have here? 80
80.
plus
36.
6 is
11.
11.6. That's it, though. That is the answer, though, isn't it? $1.16. Do you see how that?
But I messed up sort of.
I know, but I could see how your mind worked when you were thinking that up, and thanks for sharing that. That was good. Okay, here comes another one. Okay. This time you can go into the cafeteria, and they have, what do they have that's special in there? No, pizza slices, okay? And this time they're on sale and they're 99 cents. And you got tons of money in your pocket. I mean, you just got a whole lot of money today. You're just feeling real rich, okay? And you said, I am so hungry. I could eat 5 pieces. How much do they cost? 99 cents. Raise your hand when you got the answer.
How many did you say?
5 pieces. Okay. Let's see. Aubrey raised her hand real fast that time. What's the answer?
$4.95.
Okay. Cribble, what's the answer? You had a calculator. What's the answer?
$4.95.
Okay. Now, I want to know how you came up with $4.95. How did you do that, Aubrey?
99 cents I put as a dollar because it's close to it, and I just did $5 that minus 5 cents, what equals $4.95.
Which method do you prefer when you're doing these kinds of problems? What would you rather do, okay? I want to go around the circle, and I want everybody to tell me what they think is the best method. Paper, pencil, mental math, base tens, or calculator.
I think it would be pencil and paper.
Calculator.
I think calculator. I think it would depend. If it's a harder question, it'd have to be calculator. But if it's like an easier one, it would be a lot easier for mental math.
I think it would be mental math because you can round everything off to something.
I think it'd be mental math because when you go into a store and you buy a few things of the same, you're going to expect about the same about the price if you add it all up. Most of the time you'll get a reasonable answer. Maybe it'll be a little bit more when they ring it up.
Okay, can we say that there's any method that's the best method?
Not really.
No. Does it depend? Could you all agree on that one? It depends on what you're doing?
Yeah.
Okay.
Yeah.
I think the best kind of math communication, the best kind of math writing comes from feeling safe to express that in front of other people and to express wrong turns and how when somebody makes a wrong turn in their thinking that we can correct them again, but it's safe to say that out loud in front of a group of peers and your teacher so we can get that corrected.
How did the teacher reinforce the notion of reasonable when examining a solution? How did Ms. Holden encourage students to consider a variety of computational methods? What techniques were used to construct meaning and develop number sense?